Hello students, today we are in lecture number 47. Okay, lecture number 47 of chapter 4 NCERT of moving charge and magnetism. Okay student, today we will discuss 3 questions of board exam which is sometime asked in the value of 3 marks. Okay student, till now we have studied student about the force on charged particle. If any charged particle projected with some velocity v inside the magnetic field, it experiences a force, and that force we have written F, it is q v cross b. All right, or in magnitude we have written q vb sine theta. All right, this is the magnitude of the force. We have also studied if any charged particle projected inside magnetic field, it moves on circular path. All right, till here we have studied. Okay student, now one other very important point you should mention, although I have discussed, whenever any charged particle enter into a magnetic field, look at here, this is the magnetic field. It enters at certain angle. Suppose it enters at theta. All right, at an angle theta. So as soon as this charged particle will enter into the magnetic field, it will start moving on circular track, and then it will move like this one. But remember, if it is enter with speed u, it is the speed with which it enter into the magnetic field u, it will leave the magnetic field with the same speed, and the very important and the next important point, it leaves the magnetic field with the same at the same angle. Remember, this is also theta. So the angle with at which it enter into the magnetic field, it leaves the magnetic field at the same angle. This is also very important. Today we will discuss about the motion of charged particle inside magnetic field if we will project with some velocity. Okay student, but this is very important. The theta in and theta out will be same. All right, the velocity in and the velocity speed, actually not the velocity, speed in and speed out must be equal. But this particular point sometime asked in examination in 3 marks, that prove that the charged particle enter into the magnetic field, it leaves the field with the same speed. Okay student, so these are the 2 important points. I hope you have written in your notes. Now we are going to prove that the speed with which any charged particle into the magnetic field, it leaves with the same speed. All right, okay, it means magnetic field B has no capability to change the speed of circulating charge. This is the very important student. Remember, magnetic field has no capability to change the speed of circulating charge. The charge which is circulating, its speed will not affected by the magnetic field if it is constant. All right, changing the magnetic field, of course the speed can be changed. We'll study later on, but how? Let me prove it. it has no capability. Remember students, this magnetic field is a conservative field. B is conservative field. Okay, and we know that work done in a complete round alright, here speed not going to be changed. Suppose a charged particle, it is projected inside magnetic field and it moves on circular track. In one complete loop, work done by conservative force in a round trip must be equals to how much? It is 0. Alright, that is the work done must be equals to 0. And according to work energy theorem, work done is nothing but it is, according to work energy theorem, change in kinetic energy is work done. Alright, change in kinetic energy is work done and it should be how much? Equals to 0. Okay, suppose the two velocity. Alright, the two velocity. Here, the two velocity we can write it is 1. Suppose u, this is the initial velocity, and the v, it is the final velocity. Okay, my dear student, and this change in kinetic energy, that is half m v square minus half m u square, it is 0. Then here you can see v equals to u. My dear students, you can also use that converse. If charged particle enter into a magnetic field, alright, enter into magnetic field, then here the magnetic field makes an angle 90 degree and perpendicular, so the work done will be 0. So you can also prove using that concept, but this is the very simple thing. Okay, now the next important point you should remember, if you will project the next point, if you will project here the magnetic field space, I hope you understand the direction of this magnetic field. It is perpendicular inward to the plane of paper. So what is the important point actually I'm going to discuss over here? If you project any charged particle from outside, alright, from outside, be careful and try to note down. If any charged particle projected from outside, then this charged particle will leave the field. If it is projected from outside, it will leave the field by sure. Okay. If any charged particle projected from inside, then it will not leave the field and it will circulate. If the space of the field is very small and it is projected with a very high speed, then it might leave the field by making a trajectory. But a charged particle projected from inside, it revolve inside the field, circulate inside the field. A charged particle projected from outside the field, it will leave the field definitely. Alright, so this is another important point. Now the next, my dear students, we will discuss about the motion of charge. Okay, motion of charged particle in magnetic field. Motion of charge in magnetic field. Alright, motion, it means we will study the radius, time period, frequency, angular velocity, kinetic energy, etc. Okay, so here suppose a charged particle being projected and it circulate inside here it was projected with velocity v. What will happen if this is the center and the radius is r? What will happen? As this charged particle will project inside the magnetic field, here the magnetic field is B, it is the magnetic field. Alright, r is the radius. What will be the direction of force as the charged particle will reach to this point? Try to find out the direction of force. So the direction will be obtained using right hand rule. The projected in this direction, this is the direction of velocity, magnetic field in downward direction, so the force will be upward. Okay, and this force will be balanced by here the force due to magnetic field FB, and this force will be balanced by the centripetal force, it is FC. Okay, so if Q is the charge, what will be the force due to magnetic field? It is Q VB sine theta is equals to, it is the centripetal force, it is mv square over r. Alright, since theta is here the 90 degree, charge is projected in this direction and the magnetic field is in downward direction, so you can find the angle, it is 90 degree. Okay, angle it is 90 degree. Charge projected in this direction, magnetic field downward, so you can see it is the angle 90 degree. So theta 90, sine 90 will be 1. Here V will be cancelled out, so R can be written as mv over q times b. This is the radius, and this radius, remember, if mass, there are a number of charged particles projected inside this particular magnetic field and having the same mass, alright, having the same mass, same charge and same magnetic field, then radius will depend upon the velocity. If you will increase the velocity, the radius will increase, or if you are increasing the radius, of course the velocity is increasing. Okay, and the other quantity you can correlate, other relation you can find out by yourself, my dear students. All right, okay, so the one question we are going to discuss here. All right, so it is the question, it has been asked in board, my dear student. Suppose an electron and a proton enter region of uniform magnetic field. It is uniform magnetic field. This one. All right. Yes. And you projected a proton and a electron with the same speed. V are the same. This is the proton and this is the electron. And you have been asked to trace the path of these two charged particles. Alright. So what you have to just bear in your mind while solving this question. So the first thing, for which charged particle the radius will be greater. Radius will be greater. And second thing, in which direction it will orient, in which direction it will move. If it is a charged particle, of course the force will be upward, so it will move anti-clockwise, and if it is negative charge, then it will move clockwise. Very good. But now, which will make the radius greater radius? Okay, larger radius. So here the radius is, you can see from this equation, as we know that for the electron and proton the masses are different, both are projected with the same velocity, it means V is constant. Charge, we know that for electron and proton are constant, and uniform magnetic field, it means B is constant. That means R is directly proportional to M, and we know that proton is heavier than the electron and approx 1000 times heavier. Okay, not exact 1000 times, but the almost 1800 times heavier. So we can write here the mass of electron is less than mass of proton. All right. So the radius of electron will smaller than the radius of proton. So the proton will make such type of loop, but the electron will make the loop little smaller. Okay, so this is for the proton and this is for the electron. This type of question you might need to face in examination. One question I have discussed, you can solve by yourself the number of question. All right, here the first we have discussed about the radius, my dear student. Now the next quantity. The next quantity is time period. Time period. And we know that the time is distance by speed. As we know that the charged particle has to cover, what is the time period? It is the time taken to complete one rotation. In one rotation, the distance will be 2 pi r. All right. The distance will be how much? It is 2 pi r. And the speed, suppose if it is moving with the speed v, and we know that as it will change its direction, the speed, that is the magnitude, is not going to be changed, because we have discussed already the magnetic field has no capability to change the speed of circulating charge. Or a student, so the t can be written as the 2 pi r can be written as mv by qb, all right, into v will be cancelled out. So the 2 pi m by q times b, and this is the time period. Okay, my student, this is the time period. Now you can find out the frequency also. Here the time period we said, note down 2 pi m by q b. This is very important. It is the time period of circulating charged particle if it is projected inside a magnetic field. Now the frequency of circulating charge. We know that frequency is reciprocal of time period, so directly you can write the frequency, my dear students, qb by 2 pi m. All right, it is qb by 2 pi m. Now angular velocity, the next quantity, it is angular velocity, that is the omega. And we know that the angular velocity, it is, we have studied in rotation in standard 11, omega is nothing but the 2 pi f. I hope you remember. So the 2 pi and f, already we are having qb by 2 pi m. So the angular velocity is qb by m. This is the angular velocity or the angular frequency, you can say, my dear student. Already, all right, qb by m. This is the angular velocity. Okay, now let me do a very simple question over here to find the force on charged particle. Can you note down? In this chapter, you will get much interest to solve the numerical question after the BS law. All right, my dear student, that's the Biot-Savart law. Now, a question. A charge of 2 coulomb, all right, enters in a magnetic field of 2I minus 3J Weber per meter square. Alright, with velocity of 2I plus 3J meter per second. You have to find the force. Okay, let me solve this question. If you can solve, pause the video and try to solve. We know that F equals to Q V cross B. So my dear students, here the 2 coulomb, and B cross B will put here the values of V and B. Here the I, J, K. Will solve the determinant. Here the V 2, 3, 0, and B, the coefficients are 2, minus 3 and 0. Now I hope you can solve this one. Okay, my dear student? Yes, you can solve. Now the next topic we are having, it is the Lorentz force, which is very important. Lorentz force. The physicist Lorentz discussed about the force when any charged particle projected inside combined electric and magnetic field. In cross field, that is, the electric field is perpendicular to the magnetic field. Then what will be the force? And that force, that is the net force inside combined electric and magnetic field, is called Lorentz force. You can write it is the net force on a charged particle in combined electric and magnetic cross field is called Lorentz force. Alright, now we'll see the Lorentz force and then what is the application of that force. We'll try to study over here. Can you note down the definition? Alright. Student, when we talk about the Lorentz force, it has number of great applications of Lorentz force. Okay, look at here. If this is the magnetic, all right, suppose this is the electric field E and this is the magnetic field. You can see it is very clear, electric field and magnetic field are perpendicular to each other. Alright, you can see electric field, it is in upward direction, and magnetic field, it is in outward perpendicular direction. If you project a charged particle in this field, in where electric field is perpendicular to magnetic field, what you will find? Suppose if you project a charged particle in this way, all right, with velocity v, then what will be the net force? You will write the net force as force due to electric field and force due to magnetic field. Actually, this is the Lorentz force. So this Lorentz force can be written as QE plus Q V cross B, and this is the Lorentz force, the very simple. Alright, I hope you understand. This is the Lorentz force. The one application of this Lorentz force we will study today here, which is the very, very important, and it is asked several times in your board examination. It is velocity filter or the velocity selector. velocity selector, or this is also called the velocity filter. Okay, how it works actually, try to understand. Suppose, my dear students, if any charged particle projected in this direction with the velocity v, and two forces are acting. One, it is the magnetic force due to magnetic field, and the second one, it is the electrostatic force. What will happen if this Fb equals the Fe? What will happen? Yes, the velocity remain constant. Velocity remain constant. Remember, this velocity will not change. If the two forces are same, so this charged particle neither move on circular path here, nor it will disturb to go in this direction, and it will move without deviation in a straight direction. Why? Because here the F net is 0, and if F net is 0, then acceleration will be also 0. If acceleration is 0, then velocity constant, and if velocity constant, it means is speed, that is the magnitude of velocity, and direction not going to be changed, and the charged particle moves in a straight direction. Now try to understand here the velocity selector. You have to write this one in velocity selector only. Alright, now suppose we are having a tunnel. Okay, we have made a tunnel in this way. The magnetic field here, electric field in upward direction, and the magnetic field this is the outward magnetic field. Okay, we are going to project here a charged particle. Actually, the beam of charged particle, the number of charges are there, and all the charges are moving with the different velocity. What we have to do, actually, we have to separate some charged particle. We have to take some charged particle which are moving with particular velocity. Actually, what is the use of this velocity selector? Write down. It is used to separate charged particle moving with particular speed out of beam of charged particle. From beam of charged particle, there are number of charged particle moving with a different speed. This velocity selector separate, that is the filter out charged particles, those are moving with the same speed. Yes. Now, my dear students, suppose if the number of charges are moving with a particular speed, and out of that all the charges, what will happen if the charged particle fulfill this particular condition? What is the condition? As it enter into the magnetic field, okay, this charged particle, what will be the direction of force due to electric field? Of course, if it is a positive charge, then it will try to move along the electric field. This is the electrostatic force. Now, what will be the direction of magnetic force as it will enter into the magnetic field? As this positive charge is going in this direction and magnetic field in upward direction, so you can see as it is moving here, so the magnetic force will be in this direction. The force due to magnetic field. Alright, if this force and this force are equal, Fe and Fb are equal, what will happen? You will find QE is equals to QVB. Q will be cancelled out. So here the V can be written as E by B. What does it mean? It means you are having the number of charged particle, all are moving with the different speed, but you can filter out one charged particle. Which is moving with the speed V by adjusting electric field and magnetic field. Suppose the electric field is 2 Newton per coulomb, and this magnetic field is 1 Tesla, then what will be the velocity? 2 meter per second. You will get a charged particle 2 meter per second which leaves the field. Why? Because that charged particle only will experience zero force. And what about the rest charged particle? Those are not having the speed exactly equals the 2 meter per second. Actually, that charged particle will circulate in this field. In this field, that charged particle will either circulate or it will get diverted. Okay, but we will separate that goes straight without changing its direction, without changing its velocity, and goes straight. Those charged particle for which the ratio of electric field and magnetic field equals their speed. All right, so you have to write finally after this point this line: by adjusting electric and magnetic field we can select out charged particle of speed v, of velocity v. And this is the particular application of velocity selector, my dear student. Okay, so this is all about today's lecture, my dear students. In next lecture we will study about the helical path, helix. Here we have studied if any charged particle projected perpendicular to the magnetic field, but in next class we will study what will be happen if we will project any charged particle not exactly at 90 degree with the magnetic field. Okay, my dear students, thank you very much.